Hello, and welcome to another session on time, speed, and distance. In this session, we'll talk about circular races. You can provide your feedback via Twitter. My Twitter handle is @Ravi Handa. Well, in circular races, we'll talk about these three cases. That is, when two people are running in the same direction, when two people are running in the opposite direction, and when three people are running in the same direction. Let us look at them. Well, on the basis of these three cases, you can also take care of any other case in a circular race. To begin with, the first one, when two people are running in the same direction. Let's say this is your circular track. A and B are running with speeds A and B in the same direction. By the same direction, I mean that both of them are going clockwise. Or sorry, in this case, both of them are going anti-clockwise in nature. When two people are running and on a circular track of length L with speeds A and B in the same direction, then some of the key formulas are: time for first meeting is L by A minus B, where L was nothing else but the length of the track. Time for the first meeting at the starting point from wherever they started is LCM of L by A and L by B. It is very important also to understand how you got these formulas. Well, for the first one, the first meeting will happen when A has covered one more round than B. Let's say if B has covered 2.2 rounds, then A must have covered 3.2 rounds. A must overtake B. So the extra distance that A would have covered till then is 1 lap, or L. The extra speed that A has over B is A minus B. Distance upon speed, that gives me the time for first meeting. Very similarly, for time for first meeting at the starting point. Well, when will A come back at the starting point? At L by A, again at 2L by A, again at 3L by A, and so on. When will B come back at the starting point? At L by B, 2L by B, 3L by B, and so on. If any of these values in these series match, then both of them will be at the starting point. And when will it match? At the LCM of L by A and L by B. Please note that these are the timings for the first meeting. Let's say someone asks you what is the timing for the 10th meeting. It will be simply 10 times L by A minus B. Someone asks you what is the timing for nth meeting at the starting point. It will be n times the LCM of L by A and L by B. Another type of question which gets asked is the number of distinct meeting points that will exist. Well, when two bodies are in the same direction, it will simply be m minus n. But what are these m and n? M and n are nothing else but the most reduced forms of A is to B. Let's say the speed of A is 30 meters per second and B is 18 meters per second. Then number of distinct meeting points will not be 30 minus 18, but you reduce 30 and 18 to the lowest possible ratio. 30 by 18 can also be written as 5 by 3. Number of distinct meeting points in that case will be 5 minus 3, or 2. Continuing with the similar idea, when there is a circular track and two bodies are in opposite direction, that is, one of them, in this case A, is going anti-clockwise, whereas the other one, B, is going clockwise in nature. Then the time for first meeting is L by A plus B. Very similar logic. The total length that they combined need to cover for the first meeting is L, and the relative speed, since they are in opposite direction, is A plus B. The speeds will get added up. Time for first meeting at the starting point, well, that remains the same, for the very simple reason that A still keeps on coming at L by A, B keeps on coming at the starting point at L by B. When will they both of them be there? That will be the LCM of the two values. the number of distinct meeting points, that formula changes. It now becomes m plus n. And what are m and n? Same as before, the most reduced forms of a by b. If you had the same example, that is, speed of a was 30 meters per second and speed of b was 18 meters per second, this will not be 30 plus 18, but most reduced forms, that is 5:3. Number of distinct meeting points would have been 5 plus 3 or 8. Let us look at another case when there are three bodies in motion A, B and C and all of them are in the same direction. What will happen then? The time for first meeting will be the LCM of L by A minus B and L by A minus C. You may ask why? Well, L by A minus B is the time when A and B are going to meet. L by A minus C is the time when A and C are going to meet. So let's say A and B meet after every 15 seconds. So that means L by A minus B came as 15. A and C meet after every 20 seconds. That is L by A minus C came as 20 seconds. Then what will happen? A and B will meet at 15 seconds, 30 seconds, 45 seconds, 60 seconds, 75 seconds and so on. A and C will meet, if you remember what I said was 20 seconds, so 20 seconds, 40 seconds and 60 seconds, 80 seconds. If you notice, 60 seconds was common in the two values, in the two series. It was also the LCM of 15 and 20. What will happen at that 60th second? At the 60th second, A will be meeting B. At the 60th second, A will be meeting C. Now A can be at only one point at a point in time. So if he is meeting B and if A is also meeting C, that means all three of them are meeting. And that is how you got the formula for the first meeting when three people are moving in the same direction. That is LCM of L by A minus B and L by A minus C. Time for the first meeting at the starting point, it just follows what we have discussed till now. A comes back at the starting point at L by A, 2L by A, 3L by A and so on. B comes back at L by B, 2L by B, 3L by B and so on. C comes back at L by C, 2L by C and 3L by C and so on. Which essentially means it will be the LCM of the three values when all of them are at the starting point and they will meet with each other. With this, I'd like to wrap up this particular session. Once again, I request you to provide feedback at my Twitter handle, which is @ravihanda, or you can also email me on my mail ID, which is ravihanda@gmail.com. Thank you.